Alright, welcome back to the third lesson of Unit 7, and I'm gonna show you the third method to solve a linear system. So far we learned to solve linear systems by using graphing and substitution. Okay, and we are learning a new one, it's called elimination. Okay, of course, before we start, I'm gonna ask you to finish this question here first. Try to solve this question by substitution. Okay, I'll give you a couple minutes. Okay, so here we can definitely solve for y for the first equation. That means I gotta move 3 to the left and move y to the right. Hence, you get 1 over 3x minus 3 equals y. Then we're gonna plug this into the y value or the y variable there. So we are substituting, right? So 2x plus 1/2 times 1/3 x minus 3 equals 5. And now we can multiply this out. We get 2x plus 1/2 times 1 over 3 is 1 over 6. Minus 1/2 times 3, which is negative 3 over 2, equals to 5. Now we have fractions here, which is, slightly more challenging to deal with. What you can do, again, is you can multiply everything by the common denominator, so then you can eliminate the fractions, okay? So we have 2x times 6, which is 12x. 1 out of 6 times 6 is just 1x. Negative 3 over 2 times 6 is negative 9, and finally 5 times 6 is 30. So now we can combine like terms, that's 13x. Move the negative 9 to the right, we get 39. Okay, divide both sides by 13, you get x equals to 3. Now, once we have the x value solved, we can then plug this into this equation to get the y value. So y is equal to 1 over 3 times 3 minus 3. 1/3 of a 3 is a 1, minus 3, that's negative 2. So there we go. X equal to 3 and y equals to negative 2. You can always plug in these two values into the original equations and see if they are true. Indeed, they will make these two equations true. Okay, so that's the method by substitution. And I'm showing you to solve the system by elimination here. So here it says adding or subtracting the two equations in a linear system produces equivalent system, right? Equivalent system. Just like what we did last time when we multiply, by a constant on both sides of the equation for both equations, we still end up with equivalent systems. Now we can use this property to solve a linear system. Okay, so here we go. It says solve the following by elimination. Let's follow the methods here. Okay, here it says first step, multiply both equations by constants such that the coefficient of x terms or the y terms, it doesn't matter, are the same or only different by the signs. So here we have 2x, we have 3x. We can multiply the first equation by 3 to get 6x and multiply the second equation by 2 to get 6x. So that's one way of doing it. Or you can multiply the first equation by 2, so you get 14y, and you can multiply the second equation by 7 to get negative 14y. So the signs don't have to be the same, okay? And in this case, I like to multiply smaller numbers, so I'm going to multiply everything here by 3, and I'm going to multiply everything here by 2, so then we end up with 6x plus 3 times 7 is 21y, 24 times 3 is 72, and here this one, 2 times 3 is 6, 2 times negative 2 is negative 4y, 2 times negative 4 is negative 8. So that's step 1. Check. Done. Step 2 says add or subtract equations to eliminate one variable and solve the other. So add or subtract to eliminate one variable. Well, if we add them here, is that going to help us to eliminate anything? Well, that's 6x plus 6x, that's 12x, that doesn't eliminate anything. 21 plus negative 4y, that's 17y, that doesn't eliminate anything. However, if you subtract them, well, 6 minus 6 is 0x. Now you can see you successfully eliminated the x variable, okay? We have 21 minus negative 4, that's 25y. 72 minus negative 8 is 80. Okay, well, we're not going to end up with a nice answer here, but that's okay. You can then divide both sides by 25, so that's 80 over 25, which you can reduce to 16 over 5. So that is your y value. Now, once we have the y value, then we can solve for it. So again, so that's second step. Just like before, once we have the y value, then we can substitute that y value into the original equation, and then we can solve for the other variable. Now, does it matter which one we plugged in? Doesn't matter. Okay, I'm going to plug into the second one because the numbers, again, are smaller. So I'm going to have 3 times x minus 2 times y, which is 16 over 5. And that should equal to negative 4. Well, then I have 3x minus 2 times 16 is 32. Over 5 is still over 5 equals negative 4. Okay, so again, if you don't want to deal with the fractions, you can always multiply this by 5 to get rid of the fraction. 5 times 3x is 15x. 5 times 32 over 5 is just going to be 32. 5 times negative 4 is 20, or negative 20. Now I can solve for x by adding 32 on both sides. So negative 20 plus 32 is 12. Now we can divide both sides by 15. So 12 over 15. Or if you reduce this, you get 4 out of 5. So that is your x value. And again, you can always check by plugging these two values into the original equations and see if they make sense. This is going to be 8 out of 5. This is going to be 112 out of 5, which is 120 out of 5, and that is definitely 24, so check. And you can do the same thing for the second equation, and you'll see that they also will make sense. Okay, so that's how you do it by elimination. There are 2 questions here for you to try. So give it a whirl. Good luck. Okay, so for the first one here, I would, in this case, you know what? I'm going to make the y values the same, or the y variable the same. So in that case, I multiply this by 2. I multiply this by 3. So then I get 2 times 4 is 8x, 2 times 3 is 6y, 2 times 5 is 10. Then here we get 3 times 3 is 9, 3 times negative 2 is negative 6y, 3 times 8 is 24. In this case, we need to add them, right? Because 6 plus negative 6 is 0y. Again, that's how you eliminate. It doesn't work if you subtract them, because then 6 minus negative 6 becomes positive 12. Okay, so in this case, you should add them. So 8 plus 9 is 17x. 10 plus 24 is 34. Now divide both sides by 17, you get x equals 2. Once you have x solved, you can then plug this number into either equations here. I'm going to plug into the first one. Okay, so 4 times x, which is 2, plus 3 times y equals to 5. 4 times 2 is 8. Oops. Plus 3y equals 5. Moving 8 to the right, that's negative 3. And then divide both sides by positive 3, you get y equals negative 1. So there is your solution. X is 2 and y is negative 1. Now for the second one here, to be honest with you, the way it's written, I would actually solve this question by substitution because y is already solved for you. Okay, so that's what I would probably do. But I mean, it's not always just going to be y equals, right? It could be like 3y equals 5x plus 4. Then in that case, solving by substitution might not be a good idea. So what do we do then? Well, when you are solving by elimination, you have to make sure you line them up properly, right? So meaning that's x, that's y, that's a number, right? So you have to turn the first equation into something like that. So what I'm going to do is I am going to move x to the left. So that becomes negative x. Positive y is still there, and that equals to 4. Okay, so then I just move the x to the left, I get negative x. Plus y equals 4. Now, that's positive x, that's negative x, so now we should add them, right? So then we get rid of the x, because x plus negative x is 0x. So then we have 2y plus y is 3y, 5 plus 4 is 9, and divide both sides by 3, you get y equals to 3. Now we can solve for x. You can use either equation. I think it might be easier to use the first one. So 3 is equal to x plus 4. To solve for solve for x, not solve for 4. To solve for x, you minus 4 on both sides, so you get x equals negative 1. Okay, so you see, I think I told you earlier, this is why I like to solve by elimination. It's beautiful. I love it. Okay, it's pretty simple, pretty straightforward. All right, here we go. Fractions. We can solve these questions by, again, multiplying everything by their common denominator to get rid of the fraction first. Then you don't need to deal with fractions, at least for the first bit. Okay, I will show you the first one and I'll try the second one. Okay, so here what we should do is multiply everything by 6 to get rid of the fractions. Here we multiply everything by 4. Now if you multiply by 6, 2/3 times 6 is 4x. Negative 1/2 times 6 is 3y. 6 times 4 is 24. For the second fraction, 1/2 times 4 is 2x. 1/4 times 4 is plus y, which is plus y. 5/2 times 4 is 10. Okay, and now I'm going to solve by elimination. Again, I need to make the coefficient of one of the variables the same. So in this case, I'm going to multiply this by 2. So copying the first equation from here, I'm going to call this 1 and that's a 2. So I'm copying that. That doesn't change, but I'm multiplying the second equation by 2, so then I get 4x plus 2y equals 20. That's positive 4x. That's also positive 4x. So then to solve for x, not to solve for x. To eliminate x, we need to minus them. 4x minus 4x is 0x. Negative 3y minus 2y is negative 5y. 24 minus 20 is 4. Divide both sides by negative 5. Y equals negative 4 over 5. And that is your y value. To solve for x, you could put this y value into either of these two original equations or these two right here. Okay, because again, these would be a little bit easier to deal with because there is no fractions. Well, at least for now. I mean, our answer is a fraction, so we're going to end up with a fraction eventually. But at least it's a little bit less. I'm going to put it into here. Okay, so 2x plus the y value, which is negative 4 out of 5, is equal to 10. Okay, now I can, again, get rid of the fraction by multiplying everything by 10. Oh, sorry, by 5. So then I get 10x. The negative 4 times 5 is just minus 4. 10 times 5 is 50. Okay, moving the 4 to the right by adding 4 and now divide everything by 10. 54 over 10, which you can reduce that to 27 over 5. And that is your x value. Okay, so there you go. That's how you solve this question by elimination. I'll let you try part B. Okay. Okay, so for part B, again, multiply everything by 4 here, multiply everything by 8 here. Then you end up with 3x minus 4y equals 8. For the second one, you end up with x plus 2y equals 16. I'm going to multiply this one by 2. I'm going to first copy down the first equation. That's right, so 1 and 2. And then multiplying the second one by 2, you get 2x plus 4y equals 32. In this case, we should add them because negative 4 plus 4 is 0. 3 plus 2 is 5x. 8 plus 32 is 40. So this one is nice. We get x as a whole number, 8. Once you have x solved, we can then solve for the y value. I'm going to plug into, again, equation number 2. So x is 8 plus 2y should equal to 16. 2y then equals to 16 minus 8, which is 8, divided by 2, y equals to 4. Okay, so not too bad at all, right? You end up with nice numbers. Okay, so hopefully you now understand how to solve the linear system by elimination. And of course, if you do enough practice, you'll get used to it and everything should be pretty straightforward. Okay, finally, we are going to solve a word problem, and that is it for today, okay? So here is example A. It says, write a linear system to model this situation. It says, an alloy is a mixture of metals, okay? An artist was commissioned to make a 100-gram bracelet with 50% silver alloy. He has a 60% silver alloy and a 35% silver. Okay, solve this problem. Okay, well, I guess we need to write a linear system first. Okay, well, what's there to write? Well, it says he is making a 100 grams bracelet. Okay, so I'm going to say let x be the mass or the weight the mass of the 50% silver. Okay, and let Y be the mass of the 60% silver. Well, in that case, then I know right away that X plus Y should equal to 100, right? Because if I mix them, the mixtures of different silver percentage, different purity of them, I should get 100 grams of bracelet. Oh, actually, hold on a second. Never mind, it's not. Okay, my bad. This one should be 60, and this one should be 35%, because we are actually making a 35% silver. My bad. But this artist has 60% silver and 35% silver. But again, same thing though, added together should be 100 grams. Now the end result, what we want is a 50%, okay? So if I multiply the purity 60% of the silver times with the mass of X and add that to the purity of the second silver, which is 35%, and times that with the mass Y, well, this should equal to the purity of the final product, which is 50%, times the mass of the final product, which is 100 grams. Okay, does that make sense? This is the percentage, that's the mass. Again, percentage times mass. If you add them together, it should equal to a percentage times mass. Okay, so now I'm just going to simplify this a little bit. That's 0.6x plus 0.35y. 0.5 times 100 is 50. Okay, so now we have two equations, right? Here's equation number 1. Here's equation number 2. So what I'm going to do is I'm actually going to work with decimals here. I'm going to multiply the first equation by 0.6. So then I end up with 0.6x plus 0.6y equals 100 times 0.6 is 60. And I'm just going to copy the second equation and I get 0.6x plus 0.35y, and that equals to 50. Okay, now from here I can then subtract them, right? Because 0.6 minus 0.6 is 0x. We have 0.6y minus 0.35y, that's 0.25y. 60 minus 50 is 10. And now divide both sides by 0.25, you get y equals 40 grams. And now once you know y is 40 grams, then we can solve for x. We can plug into this first equation. X plus 40 equals 100. Minus 40 on both sides, you get x equals to 60 grams. Okay, that's it. Okay, that is that. I do have an extension question for you to do here. I mean, it now has 3 variables, so a little bit more challenging. I'm actually not going to go over that. If you're interested, okay, please come see me and I'll show you. But I don't think I will go over that question right here. So that is all for today. And that is solving by elimination, okay? Hopefully you understand the steps. And if you have any questions, let me know. Otherwise, good luck with the practice questions.